of these experiments, I would think that collectively, even though it's a relatively mild effect, the evidence should be adding up to something that gets close to proof that there should be a lot more work in this area. But has it reached that trigger point yet?
I would say probably not quite yet. The means to do these experiments are relatively new. If we didn't have worldwide communications and we didn't have the Internet, this would be impossible. So these technologies are new, and even the concept of doing these mass experiments as an experiment is relatively new as well. So,
okay.
10 years sounds like a long time, but in terms of the long reach of science, this is just started.
True. All right. In your book, Entangled Minds, you propose that ESP might be related to quantum entanglement, which is in itself very difficult for a lot of people to understand. Have developments in physics, and I know they're moving quickly in this area, continued to support the idea?
Well, this is an area that I've been most interested in recently. I gave a talk last week at the IONS conference, the Institute of Noetic Sciences conference. And originally I was going to talk about advances in psi research, and then I realized that we can talk. I can talk for hours about various experiments, but underlying it, what's really needed is something like a different model of reality. And unless you have that model in mind, it becomes very difficult to know even what to do with psi phenomena. So I spent a couple of months getting up to speed on what the latest developments are in quantum entanglement, because I think that, as I wrote in Entangled Minds, that the idea of entanglement is that at elementary particle stages, if photons interact, or electrons, or atoms, once they interact, they remain connected in some strange way that is counter to common sense, but nevertheless, we know that it's true theoretically and experimentally, that there's some kind of connection which persists, even in systems that have now separated. The equations of entanglement say that these connections are not in space or time. They transcend space and time in some strange way. And so in thinking about that as a phenomena, we know this is a real physical phenomena. This is a deep level of reality that we're all embedded in, that if it were true that this also emerges up into higher level systems, including biology, then we shouldn't be too surprised that occasionally our own experience is mimicked by these kinds of strange connections. Because after all, the mystery in any kind of psychic experience is that somehow you feel connected to another person at a distance or to an object at a distance, and the distance could be through space or through time. Well,
okay, but with quantum entanglement, hasn't it been suggested that distance is not a factor at all? In other words, you get a flip and a flop a mile away or on the other side of the Earth. I think that's been demonstrated, hasn't it?
It has, yes. So with the quantum entanglement effect, distance really does not matter at all. And in fact, it's been, I think the record now is something like 90 miles looking at these connections. And the speed, that the idea is that these are instantaneously connected. They look separate, but they're really not. So a recent test measured how fast the speed of light would need to go in order to see the effects that were observed.
Right.
And they found a minimum of 10,000 times the speed of light would be necessary to explain this kind of instantaneous connection. Whew. So it probably is instantly, although all we could really see at this point was 10,000 times the speed of light. So if there's a distance effect, as I mentioned in the Global Consciousness Project, it still might be an entanglement thing, which has to do with people's reactions, as opposed to something like a electromagnetic signal drop-off. So might
okay,
get...
but there is a difference. In other words, with quantum entanglement, no effect with distance, but with consciousness, you're suggesting to me measuring an effect, a larger effect closer in.
Right. And so, but again, we don't know why that is. We don't know whether it's because people near an event simply pay a lot more attention to it than people far from the event, which seems plausible, or whether there's some kind of physical actual physical effect going on at a distance. We don't know which one of those are the proper explanation. My guess is that entanglement at an elementary level, when it emerges up into chemistry and biology and psychology, that it takes on new forms. Just in the same way that when an electron turns into an atom and turns into a molecule and so on, the new form that it emerges in has additional properties that we would not know of at a lower property. So entanglement, I think, has the possibility of emerging into living systems and behaving in a slightly different way. And when I wrote this book, I was speculating that maybe someday people would find quantum entanglement effects in biology. And within the past 2 years, we now know that that's true. It's been found in photosynthesis. It's been found in enzyme activity, and most recently found in avian magnetoreception, which is
you're going to have to explain that one. Sorry.
Avian birds. Magnetoreception is they're detecting the magnetic field lines of the Earth and using it to navigate.
Got it.
So it turns out that the reason that birds are able to do that is due to a quantum coherence effect. So this is now taking these very elementary, strange quantum connections and having it emerge all the way up into a level of a living system. And previously, physicists thought, well, this is impossible because you need special states of quantum coherence, which require states that are exotic, like extremely small and extremely cold and so on. But this is no longer the case. We now know that it also exists for long periods of time in hot, wet systems like biology. So the next step is going to be finding it in the brain, and the step from there to something like a psi phenomena, I think, is a small step. And this area of research is moving so quickly that I don't think we're going to need to wait 20 years to find this. We might be within a matter of 2 to 5 years before someone makes this discovery. And at that point, as I had predicted in my book, at that point, suddenly the past century of psi data will no longer look quite so anomalous as it did before, and people will start predicting, well, maybe there should be something like telepathy. And then it'll change how the mainstream views this large body of data and, of course, the countless anecdotes that people have about these things.
Well, you speak of a different model of reality in order to even begin to understand all of this, and that's a tough road to hoe for a lot of people, a different model of reality.
It will require a kind of a paradigm shift, and I think we're still struggling with even with the idea of what quantum mechanics is trying to tell us about the nature of reality. I mean, most people have trouble thinking that everything is connected because that's not what our everyday life is telling us. I mean, I'm talking to you, but I don't feel like I'm you. I don't feel connected in that way.
Right.
And yet what we know from physics now is that at some level we actually really are connected. So unfortunately, this starts to sound like mysticism. It's one of the reasons why this kind of discussion has been stiff-armed by the mainstream, especially by physicists, because they really don't like the idea that it sounds like a giant step backwards into the Middle Ages or something.
Well, the whole quantum world kind of sounds that way. I mean, to try and I've mulled it over 1 million times, and to try and understand how this quantum effect occurs, it drives people crazy. There's no way to explain how it can happen, how two particles can act in unison no matter how far apart they are. It's just inexplicable, period. And it doesn't work with our current model of reality. It just simply doesn't work. There's no way to explain it. So,
right. So it's easier to ignore it. And the reason it's hard to think about and hard to explain is because all of our language and our ways of thinking are based on common sense, based on everyday world where things work like billiard balls. And so it shouldn't be too surprising that when you get away from the everyday world, well, maybe there are different principles that work down there, or maybe even at cosmological level. So it'll be different principles that better describe the nature of those phenomena.
Okay, but if today's theoretical physicists are willing to embrace the quantum world, which they're doing en masse right now, I would think that this would be